My name is Dr. Kate Biberdorf, but you may know me as Kate The Chemist. Today, I'll be answering your questions from Twitter. This is Chemistry Support. Psy Rehab wants to know, isn't the whole universe a chemical reaction? Yes. Absolutely, 100% yes. Chemistry is everywhere in everything. If you can see it, breathe it, touch it, it's chemistry. We're taking atoms and rearranging them into different ways, and it's just chemistry everywhere, everything around us. It's elemental. Next up from Enan Yam wants to know, chemistry lecture, why does Diet Coke and Mentos make a chemical reaction? Mentos is a porous candy, and so if you look really closely at a Mentos, all of it on the outside has these little holes, there's these little pores, and when we drop it into Diet Coke, that is immediately attractive to carbon dioxide. So all the carbon dioxide in the soda rushes to the candy, and it starts to like sit on those pores, but it's not just one carbon dioxide molecule or a second carbon dioxide molecule, it's hundreds and thousands of them slamming together at once. So as they reach the candy, they're smashing into each other here, they build up pressure and they end up shooting straight out of the Diet Coke. And so we have this really beautiful soda volcano. It has nothing to do with the Diet Coke itself. It's the fact that there's carbon dioxide in the soda and it's the shape of the candy itself. So you could do this experiment with Coke, with Mountain Dew, with any soda you want. It just so happens that Diet Coke works really well and it doesn't contain the sugar, so it's much easier to clean up. Now, HollyJean05 wants to know, in chemistry, how do you get two bonds to break up? This feels like a joke. I will say you can get two bonds to break whenever you have neighboring atoms that they are more attracted to. So let me give you an example. I don't know if you've ever heard of this, but Blake Lively and Ryan Reynolds, when they were first together, they were set up on blind dates with other people. And so you have Blake and another man with Ryan and another woman. And so they're sitting across the table from each other, not interested in their original pairing, very interested in each other. And so this is referred to as a double replacement reaction, where you start off partnered with somebody else, but then you see something that's better, a better option. I mean, it's Ryan Reynolds, so how can you? And so then you form another bond. And so now Blake and Ryan are now paired, and then these other two are not, but in theory, they could be partnered up if they wanted to. So it's as simple as that. Your atoms are more attracted to something else. Kick the PJ wants to know, just found out that my brain has chemicals inside it. WTF. That doesn't sound good. How do I get them out of there? Oh no. PJ, you want chemicals in your brain. You need them, otherwise you're not gonna be able to function at all. For example, adenosine is in your brain and that helps you get sleepy or drowsy, so it encourages your body to go to sleep. You absolutely need these molecules in your brain. Without them, you would not be a functioning human. Courtney Neros wants to know, if atoms are primarily composed of empty space, why can't you pass your hand through a solid object? So let's go to the basics here. An atom is formed with a nucleus in the center, and in the center you have protons and neutrons. So if my body was an atom, my kidneys, my liver, those would be my protons and neutrons, like inside my core. Now on the outside of your atom, that's where your electrons are moving around. So that would be like my gloves or my sunglasses or a hat, something that's on the outside. So atoms can really easily exchange electrons to a neighboring atom. I can give you my gloves, I can give you my scarf. I can't really give you my kidney or my liver. That's gonna be really difficult. So we can exchange electrons, but not so much protons and neutrons. Now the question here is, why can't you pass your hand through a solid object? And the reason being is because that nucleus is extraordinarily dense. It's very, very dense. It's got those neutrons, those protons, and it takes up a lot of space. And so yes, you can pass your hand through the spot that has all the electrons, but as soon as you slam into that nucleus, that's a dense object that you cannot pass through. Now we have Carly0575 wants to know, how do pheromones work? Pheromones are so cool. So what happens is one animal, let's say you have an ant, is going to release some pheromones, then a neighboring ant is going to absorb those pheromones into their body and all of a sudden have all these new signals, some information. So ants tell each other where food is. Other animals could possibly give out sex pheromones, so it's kind of like a way to play Cupid, and you can encourage someone else to be attracted to you just by giving those off. Unfortunately, humans don't have sex pheromones because we learned how to communicate. So if we just wink and give a little high five, usually that can send the message across. We don't need to like shove our hormones into someone else to make them attracted to us. IQ Air wants to know what's in a firework. It's a combination of potassium nitrate, some carbon, and some sulfur. So essentially what happens is the potassium nitrate decomposes, releasing oxygen gas. When oxygen is in the presence of charcoal or carbon, it's gonna burn, and the sulfur helps to create a lot of smoke. Now, there's usually a second piece in there, like a delayed timer that's going on as well. And so once that gets hot enough, that's gonna do the second boom. So the first explosion gets us all the way up to the sky, and the second explosion gives us the huge bang. Now this is where we see the colors. So if there's red, there's gonna be some strontium in there. If there's some green or blue, there's probably copper. The pinks are from potassium. Those burnt orange, beautiful colors, those are from sodium. So it's a big mixture of molecules, and it's all thanks to chemistry. Okay, next one. St. Gregory wants to know, does anybody even know what electrolytes actually are or do? I know! Electrolytes are charged minerals, so they're cations and anions in the human body. So often we see things like sodium, calcium, magnesium, maybe some chlorine, and they all make sure that your body functions properly. So they're in charge of sending nerve signals through your body. They're in charge of making sure your heart beats. Some of them make sure that you have enough fluid inside the cells, while another one makes sure that you have enough fluid outside of the cells. The chlorine is even used to help digest things in your stomach. So it's all over your body, and you need these electrolytes. And that's why if you're drinking alcohol, you usually feel like awful the next day, because you've pushed all these electrolytes out of your body, and now your body's a little bit wonky. All right, from Sci America, what's the chemistry behind home pregnancy tests? Oh, this is a great question. Home pregnancy tests work very similarly to our rapid COVID tests. So you have a piece of paper, and you have an antibody that's essentially sewn into the paper. So when a woman becomes pregnant, about 10 days after conception, we have this hormone called HCG. And what happens is you can urinate that out onto your test, and if that hormone is present in the urine, it will bind to the antibody in the test, and it will activate a dye molecule, and so that's where you'll see that like blue plus sign or the blue word pregnant or anything like that. Fun fact, like a long time ago in ancient Egypt, they used to use home pregnancy tests by having women urinate on barley seeds and wheat seeds, and if they sprouted really quickly, that hormone must be present in the woman, because that's what activated those seeds and make them sprout really quickly. So they could actually detect pregnancy with about 70 to 85% accuracy. Up next, Af Stanton asks, what is the most dangerous chemical reaction? Okay, so you have to be careful, because this question would absolutely start a fight with a gigantic group of nerds. It's like asking you which is the best superhero. In general, I would say anything with lots of nitrogens. So if we have lots of nitrogens, that usually means explosion. So there's things called azides. There's one called azidoazide, so C2N14. And that one kind of has the internet's reputation of being the most explosive. It's not really, but it's very unstable, and that's why it gets this reputation. One thing could be it would explode if you stir it. It would explode if you heat it up. It can also explode when you're not even in the room. I will never forget when my professor was talking about these explosive materials, and he said in his lab, a friend of his picked up a beaker and, just like not thinking about it, picked up his safety glasses to wipe his brow, and right as the safety glasses went up, the thing just exploded. The guy no longer can see, and I have vividly remembered that, and I am unbelievably anal about my goggles now. Bitter Mode On asks, who created the periodic table? It depends who you're asking. The very first version of the periodic table was a man who brought 3 elements together and just put them together based on explosiveness. The second guy came through and took these little sets of 3 and made triads and made little like T's with them, and so little X's. But at that point, we had to memorize all these T's, and it was really complicated. So 2 men at the exact same time, but separately, individually, so Dmitri Mendeleev and then Lothar Mayar, came together, and they organized all of our elements based on increasing atomic mass. But here's why Dmitri Mendeleev always gets the credit. He noticed a pattern. So let's say we had a pattern like 2, 4, 8, 10. There's that missing number 6. So we would see that it would go, okay, 2, 4, 6, 8, 10. And Mendeleev did the exact same thing. He was like, there are 2 elements that we are definitely missing. He saw the pattern and left holes for that in the periodic table. So 10 years later, when gallium and germanium were discovered, Mendeleev was given all the credit for the periodic table, because not only did he order it in increasing atomic mass, but he also predicted these unknown elements. Pretty cool, right? Next up, from St. Mary Tulsa, why does popcorn pop? How does a lava lamp work? And how do you make slime? Popcorn kernels have a little piece of water in there, so a couple water molecules in the liquid state. Now when we heat them up, the liquid water converts to gaseous water, so it vaporizes, but the gas takes up space and it moves around. So it's slamming against the side of the kernel, and eventually when it has a high enough velocity or enough kinetic energy, it actually pushes that kernel to pop, and now you made popcorn. For a lava lamp, equally cool, what we have is some kind of container that has usually oil on top and then liquid at bottom. And then what you need to do is somehow generate some gas. A simple way of doing this would be to add like an Alka-Seltzer tablet, which would generate carbon dioxide. And so the gas forms at the bottom of the lava lamp and it starts to pull up. As it goes up, it kind of drags the water molecules with it and they go all the way up to the top. So visually, we see the water molecules move through the oil layer. They get to the top, the gas pops, it lets go of the water molecule. Water's more dense than oil, so it sinks down to the bottom. And then the process just repeats itself. Carbon dioxide goes up, it pops, water comes back down. Over and over again. Very beautiful. Last one, how do you make slime? Fantastic question. Let me show you. You'll need about 1 cup of glue, 3 cups of shaving cream. So now we're gonna stir, stir, stir. After that, we're gonna add 1 teaspoon of baking soda. Again, stir, stir, stir. So if you're adding glitter or food coloring, now go to town. So we're looking for a nice homogeneous mixture, so it's all really mixed together. 2 tablespoons of contact solution is going to activate your slime because we're adding boron. Let this sit for like, I don't know, 30 minutes or so and let that reaction happen. But if you can't wait, like me, I can't ever wait, stick your hands right in there. Ooh! Next up from CWPSLV. So how exactly does chlorine work to disinfect your pool water? So what we usually use is a hypochlorite, hypochlorous acid buffer. It is a buffer or a solution that locks the pH into 7.52. So what happens is if you add something that's slightly acidic, the basic component of the buffer reaches out and eats that, neutralizes it, keeps the pool clean. If you add something that's slightly basic, the acidic part of the buffer will reach out and eat that and keep the pool nice and clean. Next, jack of speed. What is the difference between evaporation and boiling? Hashtag chemistry question. Are you one of my students? Because this is an exam question I use every year. So evaporation and boiling are similar, but they're different. So boiling happens at a very specific temperature. So here on Earth at atmospheric pressure, water is going to boil at 100 degrees Celsius or 212 degrees Fahrenheit. But that is always going to happen at that specific temperature. Evaporation can happen anytime. And so what happens is you have all these water molecules, let's just assume you have a glass of water. You have all these water molecules and they are moving at a distribution of velocities. So the ones that have really high velocities, really high kinetic energy, they have enough movement, enough wiggle around to actually like break those hydrogen bonds, break those intermolecular forces and move from the liquid state to the gas state. But that can happen at any temperature. It does not need to be 100 degrees Celsius for your glass of water to evaporate on your nightstand. Next up, nose, nose, nose. How does tomato juice make skunk smell go away? It doesn't. That's an old wives' tale. So what happens is you actually have what's referred to as olfactory fatigue. And so your brain just kind of stops smelling the skunk smell and you're only smelling the tomato smell. So it's basically nose blindness, that's all. Next up, G-Tesh21. How do fireflies glow? Fireflies have this molecule in their abdomen called luciferin. And what happens is they're able to essentially bring oxygen into their bodies through all these little holes and tubular pathways in their bodies. And once the oxygen hits that molecule, it reacts with a bioluminescent enzyme that makes this thing glow. It's very beautiful. All right, that's it. I've gone through all the questions. I hope you've learned something. Until next time.